Alright guys, I'm going to finish our math lesson. We are adding like fractions. It was lesson 2 of chapter 9. Right, we started on page 619. We did 620. You can pause it if you need to. And we are on, where I go, 621. Alright, so I'm adding like fractions, right? I do not add denominators because this is a division problem. And when I do division, I don't do my division first, right? I do my division, I don't do my addition first. I do my division first. So I can't do this part yet. I have to leave it in a division problem. And I'm just going to add these numbers. Right, hopefully that kind of makes sense. I can add these two numbers. I can do this addition problem up here, but then I need to divide them, right? So maybe that does sound backwards. I liked the way the guy explained it in the video, so maybe you could go back and watch that. But this fraction is not in its simplest form, so I can reduce it. I can make it smaller, right, to its simplest form. Not smaller, I'm making the exact same size. I'm not making it smaller, sorry, I don't know why I said that. So I could see that both of these numbers could be divided by 4, right? That's their common number, their common multiple, their common divisor number, that multiple divisor. All right, 4 divided by 4 is 1, and 8 divided by 4 is 2. So it equals 1/2. All right, my next problem. I don't add my denominators. I'm still going to have fourths, right? My pieces are still cut up into fourths. I'm going to add the top numbers, though, my numerators. 3 plus 1 is 4. 4 out of 4, I have my whole piece, 1. All right, so now I have ninths. I'm not going to add my ninths. I'm going to add how many ninths I have. I have 4 ninths and 5 ninths. So altogether, I have 9 ninths. Again, 1 whole piece. My next one, I have a number missing here, right? My algebra. You know, I love the algebra part. All right, so I need to figure out what number goes here. Well, I can do the same thing I do, right? We didn't do subtraction yet, but we're going to right now. So I can do the same thing I do right here. When I do, right, I could say 1 plus something equals 2. 1 plus 1 equals 2. Right? Or I could do this, right? They're inverse operations. So I know that 2 minus 1 is going to equal my number that's missing 2, right? 1. 2 take away 1 is 1. So same, I'm doing the same, I'm doing it right up here, right? Instead of having, so this is what I'm going to do. I have a square here. I'm going to leave my square. I'm going to take away 1/3 from here and get rid of it. Whatever I do to one side of the equation, I have to do to the other side of the equation. They have to be equal. So because I'm going to take this one away from here, I'm going to add it. I'm going to take it away from here also. Sorry, I'm not going to add it. I'm going to take it away. So now I'm going to have my gray square is 2/3 take away 1/3. Right, 2/3 take away 1/3 is, I'm going to write my answer right on the line, 1/3. So I do the same thing with addition. I do not add my denominators or subtract my denominators. I just leave them the same, 3. But I do subtract my numerator. 2 take away 1 is 1. All right, so now I have 5/12 plus 4/12 equals a 4th. Uh-oh. Right? It is going to equal a 4th at the end because I'm going to just change this 4, right? I'm going to this is just would be like a regular addition problem, right? I could do this without that part there. So I'll show you what I'm saying. So 5 plus 4 is 9/12, right? But I know this is still going to be equal. This is equal 5/4 plus 5/12 plus 4/12 equals 9/12. So I have 9/12. I want to turn this 12 into a 4 because I could see they want my number to be a 4 on my denominator here, right? They're showing me that. So I also could see here that I could reduce this fraction, right? Oh, do you know that 9 can be divided by 3 and 12 can be divided by 3? right? Whatever I do to the bottom, I do to the top, and I already remember my 3 times 4 is 12. So 12 divided by 3 is 4, and 9 divided by 3 is 3. So my answer, my gray square, is 3. Right, I'm just doing the gray square here. Here I did the whole fraction was my gray square. That's why my answer is a fraction. Here I'm just doing the top part of my fraction, so it would be a 3. All right, I have 3/10 plus 4 somethings equals 7/10. Well, I know 3 plus 4 is 7, right? And I know now the denominator, it has to be the same. I couldn't add 4 plus 3 and get 7 if it wasn't a 10. So my gray square here is equal to 10. All right, on to the back. Terry painted 5/12 of the fence. Ray painted 4/12 of the fence. How much of the fence did they paint all together? Well, I'm going back to my memory of my all together means adding, right? So if Terry painted 5/12 plus Ray's 4/12, so we're not going to add our denominators. There's still going to be a 12. My numerator is 9. Right, we just did this, remember? Where did we do it? Right here. 9/12, right? Remember, I can divide by 3 to make it in its simplest form. So all together, they painted 3/4 of the fence. 9 divided by 3 is 3. 12 divided by 3 is 4. All right, Megan walked 4/10 of a mile to the park. She walked the same distance home. How much did she walk altogether? She walked 4/10 there. She walked the same distance home, 4/10 of a mile. I'm going to add, my denominator stays the same, my numerator, 8/10. I can still see I can make this into its simplest form, right? And it told me to do that in the directions, right? In simplest form. So I'm going to divide by 2. I'm going to divide by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. 4/5 mile, right? She didn't walk a whole mile, but she didn't walk more than a mile. If she walked more than a mile, I'd put my S on the end, right? It'd be plural, more than a mile. It'd be miles, but it's not even a whole mile. It's close to 1 whole mile, right? It's closer to 1 whole mile because 5/5 would be 1 whole mile. All right, we're going to use some number sense, right? My sense, thinking about this. It rained 2/8 of an inch in 1 hour. It rained 4/8 of an inch in the next hour. Find the total amount of rain. Oh, there's one of my keywords. When I'm finding the total, I add. So I know it rained 2/8 in 1 hour. Another hour, it rained 4/8 all together. I'm not going to add my denominator. It's still 8s out of 8s. 2 plus 4 is 6. I do see that I can write this in its simplest form. I need to write it in its simplest form. And I see that both of these numbers could be divided by 2. Sometimes I make a number into its form, and I can see from then it can get even simpler, right? I could keep going. This one's not. I'm going to have 6 divided by 2 is 3. 8 divided by 2 is 4. Right? If they're even numbers, I could just keep dividing by 2 until I get to my simplest one, because I'm still 2 over 2 is 1, so I'm just dividing by 1, and any number divided up by 1 is 6. All right, select 2 fractions whose sum is 3/4 and whose denominators are both the same but not equal to 4. I have to think about this for a second before I... All right, so 3/4. It's going to be equal, right? 2 fractions are going to be equal to 3/4 at the end, right? So how about if I simplify it at the end? Because right now, when I'm adding them together, their denominators are the same, but not equal to 4. Right? I know one number I could turn into 4. A lot of numbers, they could have would reduce to 4, right? So, but the top is going to have to reduce to 3, right, when I have my answer. All right, so can I say that 8 would turn into 4? If I divided it by 2. So whatever I do to the bottom, I'm going to have to do to the top also. So I'm going to have to find a number I could put up here that when I divide it by 2 is going to equal 3. So how about 6? So what 2 numbers I could add together to get 6? How about 1 and 5? All right, so hopefully that makes sense, right? I'm going to put my answer over here so we could, so right, this would be 6 eighths. And if I took 6 eighths, I divided by 2 on this side and divided by 2 over here. 6 divided by 2 is 3, and 8 divided by 2 is 4. Sorry, it looks a little funny because I wrote divided by 2. I just was, right, I should have put it the other way there, but I just did it the same way I always do it. I guess because I'm right-handed, I don't know. How are equivalent fractions used in writing a sum of 2 like fractions in simplest forms? All right, so when I add 2 fractions, and they're like fractions, they have the same denominator, and I add them together, and I need to reduce them, I put them in their simplest form. All right, I'm trying to think of the easiest way to answer this. Your book says the simplest form of a fraction is equivalent to the fraction representing the sum, which is a great sentence. So I'm going to say after I find the sum of 2 like fractions, I can reduce it to simplest form by finding, and I ran out of room. I'm going to write it right here. I just have 2 more words. Equivalent fraction. Hopefully that makes sense to you guys. It makes better sense to me than the sentence the book had. The book says the simplest, I could have written it down somewhere else for you guys too, or showed you the screen. I wonder if I could share you my screen. Well, I'm going to just leave this one. After I find the sum of 2 like fractions, comma, I can reduce it to simplest form by finding an equivalent fraction. I can do a little example of this too, right? I say 3 eighths plus 1 eighth equals 4 eighths. I'm going to find an equivalent fraction and simplify this at the same time, right? Divide this by 4, divide this by 4, 1/2. 4 eighths is an equivalent fraction to 1/2. Equivalent just means they're the same. All right, hopefully that's good. And on to